Hey guys, welcome to class. This is Mrs. Brunk. Today we're going to be learning about adding, subtracting, multiplying, dividing real numbers. Well, hopefully we're going to be reviewing that. I'm sure that's something you've done before. We're going to start off with a little bit of vocabulary, and we're going to talk about what it means to take the absolute value of a number or an expression. The absolute value of a number is its distance away from zero on the number line. Now you may remember absolute value having something to do with making numbers positive. Well, that is true. That is what happens because distance can never be negative. So basically what the absolute value of a number is telling you how far it is away from zero. And that's why anything you take the absolute value of will always either be positive or if will be zero. If it's actually already at zero, it's 0 units away on the number line. Now this little diagram here demonstrates why the absolute value of -5 is 5, because clearly -5 is 5 units away from 0. It's just coming from the left. And the absolute value of +5 is also 5, because it is also 5 units away from 0. So if we had to work backwards from -5 or 5 back to 0, we'd have to go 5 units. So we're going to move on and review adding real numbers. Now when we're adding real numbers, a couple different scenarios can occur. First of all, we could be adding numbers with the same sign. Now if that's the case, if two numbers have the same sign, you just add their absolute values, in other words, kind of ignore the sign, and use then at the end the sign of the two original numbers. So if they're both positive, you add them and the answer will be positive. If they're both negative, ignore the negative signs, add them together, and just make your answer negative. And here's a couple examples of those two situations where you're adding two positives or two negatives. Now the second scenario is that we're adding numbers with different signs. Now if we're adding numbers with different signs, you find the difference of their absolute values. So in other words, you can ignore their signs and see how far away from they are each other. So find the difference of their absolute values, and then use the sign of the number with the greater absolute value. Now that might sound a little confusing, but I think when you see how we look at the example, you'll understand. So for instance, in this example right here, -8 plus 12. So we took the absolute value of the difference of their absolute values. The absolute value of 12 is 12. The absolute value of -8 is 8. So we took the difference or subtracted them, and we got 4. And then since originally the absolute value of 12 would be greater than the absolute value of -8, then we take the sign of that 12. And I can see that this got cut off a little bit. So what this should actually say at the end is that the answer is 4. Now maybe you don't really think about all those things when you're actually adding numbers with different signs. And you maybe just always learn just to do it, but it maybe would help to kind of see what goes into actually finding the sum of a positive and a negative number. We can look at one more example. So 3 plus -15. So the absolute value of those two numbers, the absolute value of 3 is 3, of course. Absolute value of -15 is 15. And then we find the difference between those, that's 12. And since the absolute value of the original number was greater for the -15, that means that the final answer will have to be negative because the -15, or the 15 was negative to begin with. So that final answer would be -12. So you may remember learning the additive inverse property. Well, additive inverses are two numbers whose sum is 0. And actually that should say whose. So we actually call numbers that are additive inverses of each other, we call them opposites. And recall from that opening example about the absolute value of -5 and 5, a number and its opposite are the same distance away from 0. So they're the same distance away from 0 on the number line, and what this means is that they have the same absolute value. Let's go ahead and take a look at example 1. So it says, will the answer to the following problem be positive or negative? Now it doesn't actually say we have to add or subtract them, But just, I'd like to do that for example A, just because it gives us a chance to review, adding fractions. So recall when we add fractions, we have to have a common denominator. Well, the denominator of the first fraction is 5, and the second one is 100, and so we clearly do not have a common denominator. But we could make it so that both of the denominators was 100 if we just simply took the top and the bottom of the first fraction and multiplied them both by 20. And that would turn the top into 20 times 2, which is 40, and the bottom into 100. And then add the negative 10 over 100, and actually I just noticed instead of using a denominator of 100, we could have just reduced the second fraction down and used a smaller denominator, but regardless, this is okay. And now when we add those together, we add the 40 and the negative 10, so you add the numerators when you have a common denominator, and that denominator will be still 100, and when we add the numerators, we get a positive 30, and that would then reduce down to 3/10. So clearly, the sign on the answer is going to be positive, so we can put that the answer is positive. And we actually see that with our own eyes, because we actually did that addition. Now looking at example B, it's probably pretty clear to you that the answer is going to be negative. So again, since they didn't actually ask us to give the final sum of the two answers, although it is -1, we can clearly see that that answer is going to be positive, and that's what they ask, is it positive or negative, and it's positive. So some of these, it's kind of tricky, so if you're in doubt, just go ahead and add them together. I went ahead and did that for C, and when I added the negative 0.0004 to the 0.0012, I got point, and then there was 3 zeros, and a 9, and that was clearly a positive answer, so again the answer is positive. So when in doubt, just actually do the addition problem and see if you get a positive or a negative one. On example D, -1 plus -1, well, of course that adds up to -2, and so clearly that is a negative answer, and they wanted to know negative or positive, and you can actually write the word, or you can put a symbol for negative or positive. Now, without actually having to go through and do the addition in E, it might be a good idea to kind of just kind of scope out how many digits each of these numbers has. So, you know, like for instance, the number on the right, the 89. Let's see what this is. This is the hundreds, thousands. Okay, this is the millions. And so this must be 89,908,745,632. And notice the other number is also in the billions, but if you look at the last digits here, the first digits, I should say, the -12 and the 89 is clearly bigger. So we know that our final answer is going to be a positive one here. And since, again, they did not actually ask for the sum, they just want us to tell if it's positive or negative. So let's review, for example, F, what this negative exponent really means. Remember, using scientific notation, which is what this is a way of writing very large or very small numbers, as the case is in this situation. When you have a negative exponent, that means this number is a very, very, very small number, very close to 0. And the negative tells us that you need to move the decimal place back to the left that many places. So this is what this first number would look like. Now that second one means I actually have to move the decimal place 14 places to the left, and that would look like this. And hopefully that would be very clear that if we added these two together, the sum would definitely still be negative. So that's a negative, and it also gave us a chance to review a little bit about scientific notation. Let's go ahead and turn the page now. Okay, so what about subtracting real numbers? So subtracting a number is the same as adding the opposite of that number. So in our example 2, we're asked to rewrite the following subtraction problems as addition problems using the opposite, and then go ahead and actually add them. So taking a look at A, if I rewrote this as addition, this would be 7 plus a -10. And then we can use the rules that we reviewed on the prior side. where we put the two together, and whichever has the higher power or higher absolute value, we use that sign. So this would turn out to be a -3. Because we're going to subtract their absolute values and use the sign of whichever has the larger absolute value. Looking at example B, we could rewrite this as 3, and then when we change the subtraction to a plus, then we have to take the opposite of what comes after it, and that makes that -12 a +12. And then putting those together, that's going to give us a +9. Now here we have another fraction problem where we're going to have to get a common denominator. Anytime you add or subtract fractions, you must have a common denominator. And so it looks like we can rework so that this first fraction has a denominator of 6, and then they'd have a common denominator. So I'm going to multiply both the top and the bottom of this fraction by 3, and that turns that into -33 sixths, and then minus 4/6, or we could change it to plus a negative. Well, now we're adding two numbers with the same sign, and that means we just can ignore the negative sign, add them together, and the final sum will be negative. And that makes -37 sixths. And I don't believe that can be reduced. Let's go ahead and look at one more. So we're going to rewrite this as a addition of the opposite problem. Oops, I made an error on the top. And that will change that to plus the opposite. So the opposite of -3/4 is +3/4. And so then getting a common denominator, it looks like we could use the denominator of 16 by adding the top, or I'm sorry, multiplying the top and the bottom by 4, which makes our addition problem look like this. 5/16 plus 12/16 for a sum of 17/16. So really you can do the same thing that you did for addition of real numbers, except for that you have to, with subtraction, you change it to addition of the opposite. So now let's review multiplying and dividing with positive and negative numbers. And to summarize multiplying positives and negatives, we're going to fill in this little table. So under multiplication, it says a positive times a blank will be a positive. Well, if we have a positive, we'd have to multiply it by another positive to get a positive. Now a positive times a blank equals negative. That means the other missing number must have been a negative, because when we have one positive and one negative, our product will be a negative. Now a negative times a blank is negative, and so that means that we have to have an opposite signed number that we're multiplying by to get a negative, and so it would have to be negative times positive again. And if we want a negative times something to be a positive for this last blank, that means that the other number must be negative as well. So two negatives multiplied become positive. So anytime you have an even number of either all positives or negatives, when you pair them together, then you'll get a positive answer. But in the cases where we had one positive and one negative, in both cases, our product was negative. And it turns out the same thing is true for negative. So a negative divided by a blank would be, a positive divided by a blank will be positive. Well, that would have to be another positive number. A positive divided by a negative would give you a negative. A negative divided by a positive would give you negative. And negative divided by negative would, of course, give you positive as well. So anytime you're dividing same signed numbers, you'll get a positive. Anytime the sign of your two numbers that you're dividing are different, then you're going to get a negative. So again, this lesson is really just kind of reviewing a lot of basic things about how to multiply and divide and add and subtract real numbers, positives and negatives. And it's also to review some really important properties. So let's take a look at this next property. Two numbers are reciprocals, and remember what reciprocal means. That means that if their product is 1, they'll be reciprocals. So for instance, if I had 3/2 and I wanted to multiply it by something that would give me a product of 1, I'd have to multiply it by its reciprocal, which would be 2/3. So a reciprocal of a number has the same sign, but essentially it's, if it's a fraction, it means it's just flipped. If it's a whole number or some other kind of integer, it means it's 1 over that whole number or integer. Now, a number and its reciprocal are called multiplicative inverses. And it's important to note that one way to divide a number, to divide by a number is to multiply by its multiplicative inverse. In other words, multiply by the reciprocal. So again, to review how to write a reciprocal, you can write the reciprocal of a number by switching the numerator and denominator. And again, if you have some sort of whole number or integer, its denominator is always 1, and so that would help if, say, you had a situation like this where you had the number, say, 6, and you wanted to know its reciprocal or its multiplicative inverse. You could simply just put 6 over 1, and then you could flip it, switch the numerator and denominator, and you know then that its reciprocal would be 1 over 6. And of course then you could show that the products would be 1. Let's go ahead and turn the page and practice a few division problems using the multiplicative inverse. Okay, so say we wanted to divide 7 by 14. Well, that's the same as saying 7 times 1 over 14, which is the reciprocal of 14. And when we multiply with fractions, remember we multiply the tops and we multiply the bottoms, and you don't have to have common denominator. So I put the 7 over 1, so it had a denominator. If I multiply across, I get 7 over 14, which is then, of course, reducing to 1/2. And we'll go ahead and pause the video, and we will have B be a you try, so you try question, and you can tune back in after you try it and check your work. So please pause the video now and try example B. So as the directions asked, I rewrote it as a product of the reciprocal of the divisor. So I rewrote it as -6 times -1/2, and when I multiplied those two together, I got a +3. Let's go ahead and take a look at one involving fractions. So we're dividing -11/2 by 4/6, and that's hard to see, but that is definitely a division sign. So that right there should be a division sign. And so when we divide with fractions, again, multiply with fractions, we don't have to have a common denominator. So when I rewrite this as a multiplication, remember the first fraction stays the same. And so then when I change it to multiplication, I have to flip the fraction that comes after it, making that 6/4. And at this point, you can reduce if you want to, or you can go ahead and multiply and then reduce at the end. I think that's what I'm going to do. So when I multiply the numerators, just go straight across the top and then straight across the bottom. And that's going to give me a -66 over 8. And then I can reduce from there, which I believe would be -33/4, because we can divide a 2 out of each one of the terms, the numerator and the denominator. Let's go ahead and set this to be a you try question, part D. So I'll have you pause the video, and yes, again, this is a division sign. So go ahead and pause the video now and divide those two fractions. Okay, thanks for giving that a try. I went ahead and did my canceling before I multiplied, just to make it a little less reducing to do at the end, or no reducing to do at the end. And my final answer was -5/12. So we're going to wrap up this lesson by looking at some properties of 0. Now recall, when we multiply any number by 0, the product is always 0. So for example, if I multiplied 5/8 by 0, I'd get 0. If I multiplied 12,437 by 0, I'm going to get 0. Any number times 0 is 0. Now what about if we divide 0 by any number? Well, 0 divided by any number is just simply 0. So the quotient of 0 and any number is 0. For example, if I wanted to divide 0 by 12, well, that's 0. So anything multiplied by 0 is 0. 0 divided by anything is 0. But what about if we tried to divide a number by 0? Well, division by 0 is considered to be undefined, because it'd be like you're saying, I have a number and I want to divide it up into 0 parts, which is just really impossible to do. So we say that that's undefined. So for instance, if we had something like 6 and we wanted to divide it by 0, that is not going to be 0. It's actually undefined. We cannot define that because there's really no way to define 6 being divided up into 0 parts. And if you try to input that in your calculator, you're going to get an error message. So let's finish up the lesson with a couple quick examples. They, in example 4, would like us to tell whether the answer will be 0 or undefined. So example A, 0 divided by 16.568. Of course, that's 0. We're taking 0 and dividing by some number other than 0. B, 63 and 7/8 divided by 0. Well, again, I'm dividing by 0 anytime the 0 comes after the division sign or it's on the denominator of a fraction. That means this is undefined, and so we cannot define a value. So we'll say undefined, and sometimes we'll say they'll use the empty set symbol like that. C, 1 times 0 is, of course, 0. 0 divided by 0, well, anytime we're dividing by 0 here, again, got a denominator of 0, that means that that's undefined. And then the final example, 0 divided by -1, well, it doesn't matter. As long as 0 is the numerator but 0 is not the denominator, then our quotient will always be 0. Well, that actually does it for today in our review of adding, subtracting, multiplying, and dividing real numbers, including positives and negatives. And also some of the properties of 0, 1. We looked at additive, inverses, and multiplicative reciprocals. So I'll see you in class.